Hello! Today I'm going to talk about assets and balances pallets, their similarities and differences, the cases to use one or another, and also basic concepts you need to be familiar with working with these pallets. Pallet balances and pallet assets are two prominent examples related to token management. Both pallets incorporate robust security measures to prevent unauthorized access, double spending, and other common blockchain vulnerabilities. Though both pallets deal with tokens and asset management, they are used in different contexts and serve different purposes. The Pallet Balances module is the fundamental component of Substrate-based blockchains and is primarily responsible for managing the native currency of the blockchain. It is designed to handle essential financial operations, such as transferring the native currency between accounts, managing account balances including checks for existential deposit to prevent inactive accounts, supporting basic financial operations such as fees, slashing, staking, and rewards, managing account essential deposits. There are the following use cases. Pallet Balances is ideal for blockchains where a single native currency is sufficient, such as public blockchains like Polkadot or Kusama. Perfect for managing transaction fees, slashing penalties, and other native currency mechanisms. Enables governance decisions affecting the native currency supply, inflation, and other economic policies. Used for systems where the native currency plays a crucial role in staking and governance. The Pallet Assets module, on the other hand, is designed to manage non-native, user-defined assets. It provides a more flexible and extensive system of handling a variety of tokens, supporting more complex use cases such as token issuance, multiple asset management, and custom assets that may not be the blockchain's native currency. Pallet Assets allows the creation and management of multiple assets, each with its unique properties and configurations. Supports operations like minting, burning, transferring, freezing, and inspecting balances of custom assets. Assets can have zero or fractional balances without needing a minimum balance, unlike Pallet Balances. Allows users or developers to create new assets and control their supply, transferability, and other attributes. Provides a comprehensive set of operations such as transferring, freezing, burning, inspecting, and managing asset metadata. Enables the creation of custom economic models for specific assets, including governance tokens, utility tokens, etc. Pallet Assets is suitable for applications requiring multiple tokens like decentralized exchanges, DeFi platforms, and NFT marketplaces. Supports the creation of utility tokens, stablecoins, governance tokens, and other specialized assets. Useful for implementing complex financial instruments such as derivatives or tokenized assets. Widely used for DeFi projects for creating and managing various financial instruments and custom assets. Facilitates the integration of custom assets with other blockchains, enabling cross-chain asset transferring and trading. Before we take a deeper look at what these pallets are actually capable of, I suggest to take advice of the code authors and look at the following links. Here they explain how to manage and implement tokens using different approaches. They highlight the difference between trades and their implementations, which allows for more flexible and modular development of custom token logic in blockchain projects. Very useful information. Also, it is useful to take a look at the fungible and fungible traits before starting work with these pallets. Fungible refers to tokens interchangeable with one another, meaning that each unit of the token is exchangeable on one-to-one basis with any other unit of the same token. For example, 1 KSM is equal to any other 1 KSM. This is in contrast with non-fungible tokens, NFTs, where each token is unique and has its own value. So again, this documentation is pretty important to look at during work with these pallets. What I'd like to do now is to take a deep look at the terminology here, as it's really tricky. Total assurance, the total number of units in existence in a system. Okay, got it. Total balance equals free balance plus held balance. Free balance equals total balance minus held balance. Held balance. This one's a bit tricky. So it still belongs to the account holder, but it is suspended and it is used in most of the cases for slashing purposes. Slashing means when account is being punished. So during slash, first the free balance is taken and after that the held balance is taken. So holds are stacking. And here's an example when if you have 3 holds for 100 units, this means you have held 300 units and they cannot be spent. Frozen balance. So the frozen tokens cannot be transferred. And they can be more than total balance, which is done for preventing any spending on particular account. So multiple freezes overlay, and if in the same situation when we have 3 freezes for 100 units, it means that only 100 units are frozen. Some balance is frozen when it is used for voting or staking or bonding, and one could use held balance for voting, but nothing prevents this frozen balance from being reduced if the overlapping hold is slashed. Minimum balance, aka existential deposit, aka ED. So this is one of the easiest one. This is minimum balance required to create or keep an account open. This is to prevent dust accounts from filling the storage. So this is done to incentivize users to clean up after themselves and not generate multiple accounts which don't cost anything, but take space on chain. Untouchable balance. This is existential deposit and freeze, the ones that cannot be spent. Spendable balance is equal to total balance minus sum of hold and freeze. Imbalance, well, this is basically when something went wrong. And we can take a look at this graph here. So we can see the total balance. We can see that on hold and frozen balances overlap, as we discussed. And we can see that free balance, this is total balance minus on hold balance. We can see that untouchable or unspendable are existential deposit and frozen minus on hold. And also what's left is spendable. This is what can be spent immediately. This is This is total balance minus untouchable and minus on hold. Every hold and freeze is accompanied by a unique reason, making it clear for each instance what the originating pallet and purpose is. Okay, and also hold and freeze reasons should remain in your runtime for as long as storage could exist in your runtime with those reasons. Otherwise, your runtime state could become undecodable. So, regarding the runtime, I would like to explain a little bit the difference between Pallet and runtime. Let's imagine Substrate framework as the basic logic of the website. For example, login account, some payment infrastructure, delivery function, and so on. And runtime is when the website is actually made on top of this basic logic, when you customize your runtime according to your needs. After all this, I need you to remember something before looking at the pallets. Held is reserved balance. Frozen equals locked balance. And spendable equals usable. Okay, I know, not everything at the same time, so I will leave a little note for you here while we are working with the pallets. So now let's take a look at the Polkadot org to see how it works. Here, we're on Polkadot org. We go to Accounts, and here you can see your accounts connected to the wallet. So here's my account, and right here we can see that there is total balance and transferable balance, and also that they're equal in this situation. Actually, they were frozen, not all of the sum, but 20 something dot were frozen to get the verification. But somehow it's gone now, so it's all transferable, can be transferred at any minute. Let's take a look at Kusama. Here also my accounts, it looks the same. Here's account. And here we can see that there is total amount, there's transferable amount, which is not a lot, there's locked and bonded amount. So it means in this situation that it is locked because it is on staking. And this is why we can see this nominator flag here. So what can we do with this money? There's some functions here as well. For example, address book, if you have some particular addresses, and you want to give them name and store them on your account. You can claim tokens. This is for bounties, and transfer. That's what we're interested in. So while transferring, you have the account you're transferring from, and you have the address you send in to. I'm not setting it now, but it can be someone from your address book, or you can put the address right here, inserted. Here we put the amount that should be transferred. And here we can see existential deposit we talked about earlier. So here it is hiding. This function is checking that account should be kept alive. It means that until the existential deposit stays on the account, it will be functioning as regular. So to prevent this account from death, we have this button here. If we turn it off, then there is a chance, so I can put the sum of money I have, and I can transfer everything, including existential deposit, but then my data will be deleted after the transaction. Here we press Make Transfer. Here we can see Sign and Submit. So now we need to talk about signed and unsigned transactions. Signed transactions are the most commonly used ones, and they use signature of the account who's sending the request to execute the runtime call. And typically the request is signed using the private key of the account that is submitting the request. And in the most cases, the account that is sending the request is also paying the transaction fee. And for more details on fees and tips, you can go to the transaction payment palette, which provides the basic logic on fees and tips. Unsigned transactions, on the other hand, don't require signature, and they don't take any personal information on who submitted the transaction. But there needed some additional implementation to protect the network from attacks and spam. That's why unsigned transactions consume more resources than the signed transaction. So here we can include tip to give more priority to our transaction. And to do the transaction unsigned, we turn this button off. And then just sign, put the password, and that's how the transaction is done. Also, we should take a look at the extrinsics to see what extrinsics the Balances palette has. Here we can see all the calls from the Balances palette. Actually, not all of them. There's no burn call here, but there are almost all of them used by Kusama and Polkadot as well. Force adjust, total assurance, force set balance, transfer, unreserved, transfer all, transfer allow death, transfer keep alive, upgrade accounts. Now we will take a look at the Balances palette. We've learned a lot about the Balances palette, and now we can see, for example, it will be helpful to take a look at the events. And here we can see the logic that is used for managing the native token of the project. So there's account created and there's account removed. As we discussed before on the Polkadot.js org, if the existential deposit is spent, then account is removed from the storage. Here, this event, transfer balance set reserved, that's where it is useful to take a look at our node. Unreserved, reserve repatriated, final argument indicates the destination balance type. Moved from the reserve on the first account to the second account. Withdraw, slashed, minted, burned, that's what not used in Polkadot and Kusama. Here we can see the calls where all this logic is set. Here it starts from transfer allow death. This is what we've discussed. force transfer, except the origin must be root. So when it says ensure signed, this is what we've also discussed earlier. Ensure signed, this is when the transaction is signed. We saw how to do that it is not unsigned transaction. And when we see ensure root, it means that sudo should make this call. And sudo is the super user account with special privileges on the blockchain. So there's index 1 missed. Then there goes transfer keep alive. This is when existential deposit is not used in the transaction. Transfer all. Force unreserve can only be called by root, so only sudo can call this transaction. Upgrade accounts. Force set balance. Everywhere there are comments on what these calls do. There's burn. We found this call, this extrinsic, that is not used by Polkadot and Kusama, but I'm sure it's used by other projects who needs this logic. And also, so let's see, there are 10 calls, but -1 because first index is skipped. So there are 9 extrinsics in the balances palette, but they provide the basic logic on the native token management. And further we can see some logic for the instances of the palette. Instances, this means that there could be several instances of the same palette, but with a little bit different implementation. Now let's take a look at the assets palette, what extrinsics it has. Oh, so Kusama and Polkadot, as it was mentioned earlier, they don't use assets palette because these are the projects with only native token, KSM for Kusama and DOT for Polkadot. So we need to find, for example, assets hub, which is a good example for taking a look at the assets palette because they use all of the extrinsics that are mentioned in the palette. So here is approve transfer, block, burn, cancel approval, clear metadata, create, destroy. Let's take a look at the assets palette. There's terminology here, and also for better understanding we can take a look at the same description but from here. There are links that state useful trade implementation, fungible trade implementation, and also there's some info on the Pallet Assets terminology and description and the functions that are used there. Pallet Assets. We can do the same, take a look at the events to have the basic understanding of what's going on here. So here, unlike the balances palette, there's specific logic for creating and managing assets. Some additional tokens apart from the native token. There could be asset class created, the tokens issued, transferred, of course, burned, can be, the team can be changed, the owner can be changed. There's some logic on asset being frozen and unfrozen, and also the same for the accounts themselves, and additional asset management logic. So we can take a look at the extrinsics. I want to mention that there are 32 of them, unlike the Balances palette, which has only 9. So there's much wider logic in the Assets palette. So there's asset creating, basically almost all of it we saw in the events. So we can make conclusion that there is, of course, more logic for the assets because they need to be managed, they need to be transferred, they need to be issued, and this is used, for example, for the bridges. When the assets can be teleported, this means that in one network, on one project, the amount of the tokens being burned and it's being minted at the same moment on the other project, on the other network. That's how you do teleports on the bridges. Transfer keep alive. So there are some calls that have the same names and the same logic as the ones in the Balances palette, but they have bigger infrastructure because you need to mention the asset ID and asset status and stuff. So we saw that Assets and Balances palettes have a lot in common. Such operations like transferring, burning, freezing, thawing, withdrawing, but it needs to be mentioned that, and you can see that Assets palette doesn't cover all of the functions that covers Balances palette. In most of the cases, Assets palette is used together with the Balances palette because that's how they make it work together. Balances palette helps to manage the native token and Assets palette helps to manage the non-native tokens. So I hope this video was useful for you. Thank you. Bye.